Hi everyone, and welcome to the part 3, Target 19 notes video for our next section of notes in Unit 7 here. And so obviously you can tell we're still talking about circles, but today we're going to try to differentiate the idea and understand the difference between this. Okay, so over the last couple units, or other the last couple parts, especially last part, we talked about how every single circle measures 360 degrees around. So if I draw this circle, it measures 360 degrees all the way around it. And if I draw this circle, that also measures 360 degrees all the way around it. But if you're, looking at these two, you should be able to tell that this one is small and this one's big. So how can they both measure 360? Well, they can, and they both also measure something different related to 360, but not exactly a degree measure. And the reason is there's different units of measurement and different ways that we try to measure a circle. And so if we're talking degree measures like 360, that's specifically, how many degrees to go around the whole circle. But let's say and that's the same in every single circle. But let's say we ask the question, how many inches to go around the circle? Well, that's a completely different question. Remember, inches not necessarily doesn't have, anything directly to do with degrees. And so if somebody asks inches, you wouldn't say 360 inches. That doesn't make any sense. They are different units of measurement and they measure different things. Again, the degree measure in every single circle is always 360 degrees, small or big. But if we were to take out like a tape measurer and we measured the distance it took to go around these circles and the distance it took to go around, small and big circle, and it was measured in inches or feet or centimeters, it would be different. It takes more centimeters to go around a big circle than it does to go around a small circle. And so again, that's really what the basis of today is. Understanding the difference between what we've talked about in the previous parts of the 360 degrees being the degree measure of a full circle, and the difference between that and understanding, how does a length apply to a circle? Where does length come into play? Because big circles have to be bigger than little circles, right? And they have a bigger length, even though they have the same degree measure. So let's get to some specific answers that help you with that. And our first box here is going to have us talk about the circle perimeter formula. Now, we have a different word for perimeter when we're talking about circle. We call it circumference. And so circumference literally means perimeter. So the circle perimeter formula is going to have us find something that we call circumference. And the formula for circumference is just, and actually we'll write it in two ways. Circumference equals pi times your diameter, or, and keep in mind we abbreviate circumference as just big C, or circumference equals 2 pi times radius. And let's draw a powerful picture to figure out why these are the same thing. If I draw a line there or a dot in the middle of my circle and connect from my dot to the edge of the circle, that's a radius. Anything coming from the center to the edge is a radius. Now, if I draw a line on the exact opposite side, that's a radius too. And so I have now drawn two radiuses in this picture. But I've drawn them in a specific spot, right? Because they are resting on the edges of the circle, but they're going through the center. And so not only is this two radiuses, but combined, we would call that the whole thing a diameter. And so that's why we have two formulas. It's based on your radius or a diameter, but because your diameter is either twice as big as your radius, or your radius is half as big as your diameter, we can use either measure in this equation. And so if you want to use diameter, it's simply just pi times your diameter. But since your diameter is 2 radiuses, if you want to use the radius, you can use radius, but then you also multiply it by 2. So it's not just pi times radius, it's pi times 2 radius, or 2 pi r. So again, either of them are you can use either of these, diameter or radius, but if you use diameter, no 2. If you use radius, there is a 2. And so we're just going to use whatever they give us in these problems down here, and so let's do this. In number 1, we want to find circumference. And so they have given us a radius. From the center to the edge is a radius. So let's say r equals 6. And we can find circumference with a radius, right? We would use 2 pi r. And so our circumference would be 2 times pi times 6. And all you have to do is type that into your calculator. It says round to the nearest tenth. Let's talk about exact numbers for a second. So we know that pi is 3.14159 and so on, right? It never ends. And so if we type pi into our calculator, we are definitely going to get a decimal. If we don't want a decimal, we don't have to type pi into our calculator. Multiplication works in any order. So this 2 times pi times 6, I could easily just do the 2 times 6 first and not multiply the pi. 2 times 6 is 12. And so I could write 12 and then just leave the pi there, and that could be my final answer. And notice the units are inches, so I'd still write inches. And we would call this answer exact. The reason is there's nothing rounded, there are no decimals. We just multiplied the 2 and the 6 together, and we got 12, and the pi just maintains its value by leaving it as pi. And so that's an exact answer. If we wanted a decimal answer, I'll even help you here. Let's go to our calculator. We would just type in the whole thing, 2 times pi times 6. And so let's go to my calculator, and I'll do 2 times, and then you'll see that pi I need to hit is a blue thing, so I need to hit second first, and then that triangle button, and I'll get pi, and then times 6, enter, and there it is, 37, and I would round that up to 0.7, 37.7. Now, real quick, just to show you, I did the whole thing here, 2 times pi times 6, but if I would have typed in 12 times pi, kind of like our exact answer, what you'll see is that'll give me the same decimal, right, 37.7. And so 12 pi is the exact answer, 30.7.7 is our rounded answer. Both of them are equal to each other. It just depends on how you like to do it or what the instructions say. If they say round to the nearest tenth, we can do 37.7. If they say exact, we will leave the pi in it as 12 pi. All right. Now, just to wrap up this entire long conversation, we have finished this off. Our radius was 6, so we plugged it into the 2 pi r formula, and we got 12 pi, which is also equal to 37.7 inches. And so either one of those answers is our answer, is a perfect answer. Now, let's go to number 2. So for number 2, they've given us a diameter, right? This line goes all the way across the circle through the center. So this time d equals 16. Split this off a little bit. And so our circumference formula can work with d, but then it's just pi times diameter. We don't have the 2 in there. And so our circumference will be pi times 16, which is really nice for exact form, right? Because we don't even have to multiply anything together. Our exact form answer is just 16 pi, and this time centimeters. Or if we type pi times 16 into our calculator, we should get 50.3 centimeters, right? Either one of those, good answers for now. Or not for now, forever. Those are great answers for this problem. All right, now let's do number 3. They want us to work backwards. So we're gonna have to do a little bit of algebra here, all right? They want radius, we don't know that, and they've told us what the circumference is. And so I'm always going to do this equation, and I'm going to find my diameter first, and then I'm just going to divide that by 2 because your diameter is twice as big as your radius. But I think the algebra to start is much easier if you find the diameter first. And here's what I mean. Circumference equals, and with a diameter, right, pi times diameter, so pi d. And so if I know the circumference is 40, I can plug that in for the c part. So 40 equals pi times diameter. And so if I want to know my radius, I need to figure out my diameter first. And then I can just divide it by 2. Well, to figure out my diameter, I just have to get d by itself on this side of the equation. Right now, it's locked in here with a pi. And you've heard me say pi times diameter a couple times. And so if we just want to get rid of the pi, we got to do the opposite of that. So we will divide both sides by pi at this step. And the pi's will cancel out. And that leaves us with what my diameter is. And I just need to type 40 divided by pi into my calculator. So let's do that. 40 divided by, and then remember the second button and that triangle. So 40 divided by pi, and we get 12.7. So I'll come back here, and that I will write down that my diameter is 12.7. Remember, they asked for the radius though. And so to get my radius, I just take my diameter and I divide by 2 because your diameter is twice as big. So if I just go back to my calculator and without hitting anything, just hit the divide button because it'll store your last answer, hit divide by 2, enter, and that's what my radius is. That'll need to be rounded up to 6.4, but either way, that's my radius, 6.4. Now, notice units say meters. We'll throw a little meters in there, 6.4 meters. All right, now let's do it one more time. But, and this is actually nice, notice they're giving us the circumference again, but there's a pi in it. And so they're giving us circumference in exact form. And this is actually the best way for them to give you the information. Watch what happens. So we want our radius again. I'm going to start by getting our diameter and then just dividing by 2. And so remember, circumference equals pi times diameter. And so I know my circumference, so I can plug that in for C. So 26 pi equals pi times diameter. And so if I want my radius, I should get diameter by itself. So I'm going to divide both sides by pi again. And here's why having the circumference in exact form is so awesome. When I divide the right side by pi, these pi's cancel out. But over on the left side, there's a pi in top and bottom as well. And so those pi's just cancel out. And it just leaves you a 26 on the left and our diameter on the right. And so when all the pi's cancel, we get 26 equals diameter. And again, we don't want diameter, we want radius. And so we're going to divide that 26 in half to get our radius. 26 divided by 2 is just 13. And that's what our answer is. Now, it's units of inches, so we'll put inches, but there we go, 13 inches. And so again, just to recap, the reason why it's so awesome when they give us circumference in the exact form is because when we divide both sides by pi, all the pi's just cancel out. And it just leaves us with our number left. And it actually makes the algebra pretty nice. All right, so that's working with circumference. Now, let me introduce just real quick arc and arc length. And then we will use that to go find partial circumferences. And we'll discuss that more clearly in the next video, but let's try to fill out this box real quick. Now, what an arc is part of the circle. It's just part of the circle. It's not the whole circle, it's just a little section. And so let's draw some things on this circle. Put a center. I'm going to put something down like this. So here's like an angle coming out of the center. We call that a central angle. We'll put a J here. We'll put an L here. And then on the back side, I'm just going to put a third point on our circle, and we'll call that point N. And so a couple things I just want to show you. Let's say that we knew this central angle measure. That's 110 degrees. After yesterday, or after part 2, you should know now that central angles equal arc measures. So from J to L, this is 110, right? Central angles equal arc measures. And so we can write that down. The measure of JL, of arc JL, equals 110 degrees. Now, I'm going to pause it here, and we'll continue this conversation in the next part of this notes video key. Thank you very much.